Welcome to day 42 of the school year. All right. Let's go ahead and get down our beginning fraction. We have 180 total school days, and we're on day 42. Let's go ahead and find all the factors of our numerator, which is 42. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, we can also write it as 42 times 1. Now we're going to go through our divisibility rules in an orderly fashion so that we don't miss any possible factors. After 1, we try 2. The rule for 2 is that it ends in an even number. 2 is even, so 2 is a factor. 2 times 21. 21 times 2. Now we try 3. The rule for 3 is that we add the digits together. 4 plus 2 is 6. 6 is a multiple of 3, so 3 is a factor. 3 times 14. 14 times 3. We try 4. One thing to look at is if the second factor with 2 is even, and 4 will be a factor. 21 is odd. Also, 4 times 10 is 40, and then 44. 42 is not in the list of multiples of 4, so 4 is not a factor. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 2, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. Both of them are, so 6's. 6 times 7. 7 times 6. There are no natural or counting numbers between 6 and 7, so we're done. Let's go ahead and list our factors from least to greatest. 1, 2, 3, 6, 7, 14, 21, 42. We have 8 factors. That is more than 2 factors, so it is composite. And now we have to figure out which one of these is our greatest common. So let's start with our greatest, 42, and then keep working until we find one that is common. That means it works for both. So 42, your groups of 42 do not have to look like mine, but you do have to have 42 in each group, and we keep our shaded separated from our unshaded. So here I have 8 plus 30 is 38. So I need to add 9, 10, 11, 12, 4 more to get to 42. Here we have 6 plus 30 is 36. Add 6 more to get to 42. 4 plus 30 is 34 plus 8. I have 12 left over. I have a remainder, so that means that 42 is not a factor of 180. It's not common. Did not work for both. Let's try the next one, which is 21. Again, keep your shaded separated from your unshaded. So 20 plus 1, 19 plus 2, 18 plus 3. Yours do not have to look like mine. 17 plus 4. 16 plus 5. Kind of like makes a pattern though the way I'm doing it. 15 plus 6. 14 plus 7. 13 plus 8. And I still have 12 left over, so that means 21 didn't work. All right. So let's try 14. 10 plus 4. 6 plus 8. 2 plus 12. Remember, your groups don't have to look like mine. We just have to have 14 in each. So 8 plus 6 is 14. I'm going to use decomposition to help me. 4 plus 10 is 14. Okay, over here, I'm going to use 7. 10, take away 3 is 7. 2 groups of 7 would be 14. Let's see, our 2 groups of 7. Because 2 times 7 is 14. And then here 9, 12, 13, 14, 7, 10, 13, 14. And we have 12 left over again. So that means 14 didn't work. Let's try 7. Remember to keep your shaded separated from your unshaded. We need groups of 7. So I'm going to do 7, because 10 take away 3 is 7. And it looks like this time I have 5 left over. So 7 didn't work. Let's go ahead and try our next one, which is 6. So 10 take away 4 is 6. Try groups of 6. Keep your shaded separated from your unshaded. And make sure there are 6 in each group. If you can use your understanding of numbers, how they decompose or break apart, that can help you get these groups done more quickly. But if you need to count, go ahead and count, because I'd rather you get to the right answer slowly than the wrong answer quickly. Looks like 6 worked. There's no remainder. So we finally found our greatest common factor of 6. So let's count up our total groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 total groups of 6. And we have 1, 2, 3, 4, 5, 6, 7 shaded in. Okay, so we've done the division with our model. Let's go ahead and do it with our algorithm. So we're dividing both by our greatest common factor, because we put the shaded into groups of 6 and the unshaded into groups of 6. So it's always the same amount. Okay, so let's go ahead. 180 divided by 6 and 42 divided by 6. Let's see, I know 20 times 6, the placeholder moves it over a place. 2 times 6 is 12. Numbers the same, 0 is a game, more on top, no need to stop. 10 times 6, well, that just moves it over a place to the tens place, I get 60. Numbers the same, 0 is a game, so that's our remainder. Here 6 times 5 is 30. More on top, no need to stop. More on top, no need to stop. And 2 times 6 is 12. Numbers the same, zeros the game. Now you may have already known that 7 times 6 is 42, but if that is a multiplication fact that's hard for you, use the ones that you can do, which most of you can do your 5s and your 2s. Then we add them together. 5 plus 2 is 7. Oops, I forgot to add these. 20 plus 10 is 30. Now we still need to check with our inverse operation. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0 for both of them, and the identity property of addition says when you add 0 it stays the same, we don't need to actually add the 0. 6 groups of 0 is 0. 6 groups of 3 tens is 18 tens, which is 180. 6 times 7 is 42. So 42 matches our dividend up here, 42, check. 180 matches our dividend of 180, check. So our numerator is definitely 7, and our denominator is definitely 30. All right, now let's go ahead and fill in our data collection page. All right, it is trimester 1, week 10. Today is 10/8/18, and our fraction is 7/30. Let's go ahead and get our number line. We did groups of 6. So we have a lot to fill in because we only have 1/30. That means we had a lot of equivalent fractions in lower terms. So here, 2/30. Well, both of those are even, so they could both be divided by 2 and get 1/15. 3/30. Both of those could be divided by 3 and we get 1/10. 4/30. Both of those could be divided by 2 and you get 2/15. 5/30. Both of those could be divided by 5 and you get 1/6. Looks like there's 2 more below it that are equivalent in lower terms. Then we get 6/30. Well, both of those are divisible by 6, so you get 1/5, and it looks like we have a lot of equivalent fractions in lower terms there, and even one up here in higher terms. And then today, 7/30. We have no equivalent fraction in lower terms, but we do have a couple up here that are equivalent in greater terms. So this is our simplest form today. Okay, thank you for joining me. Okay, go ahead and put away your number line, erase your worksheet, and thank you for joining me.